Welcome to Module 6.3. We are going to be looking at how to multiply and divide algebraic expressions. You'll remember that in the last module we looked at how to add and subtract algebraic expressions. And these are quite different processes, so make sure that if you're unfamiliar with how to add and subtract, you go back and look at Module 5 and then make sure that you know how to multiply and divide using this module in the lesson here. So our objectives are going to be to multiply and divide algebraic expressions. And so we're going to just use simple factors. Remember that we defined factors in the last module. They're terms that have the same literal parts, and sometimes in addition and subtraction, they have to be the same parts. Remember that the terms need to be similar in addition and subtraction, the same families. Remember I described it as that. In multiplication, in division, it's different because you can have two different terms and you can multiply or divide them together. Say, for instance, 2x and 3xy. You can multiply those together. However, in addition or subtraction, those terms would be kept separate from each other. So let's look at this. An example would be a times 2a, and then basically what we have is we have the numerical coefficient of 2, and we have two a's, and so those two a's multiplied times each other end up being written in an exponential factor of 2. So we have 2a squared. And think of this as if you would think of maybe looking at the area of something. If you have one side times the other side, s times s, and let me go ahead and draw that out. And so the way that works graphically, if you have side labeled s and side labeled s, remember what we end up getting when we multiply these together is the area in there, and that area is reported as s squared because you're multiplying s times s. Same thing when you are multiplying other factors together. So looking at example B, 2x squared times 3xy, different terms, but we'll go ahead and take the factors and we'll group them together. Put all the x's together, you end up with 3 of them, so you get x to the third and then 1y. Then also note that we're taking the coefficients and multiplying the coefficients together, so 2 times 3 is 6. Now, notice I said that those are the coefficients. Don't confuse those with the base, which is the x or the y. And so, because sometimes, and let me go back to that, because sometimes that x or that y is the base, it might be a number. And so if that, instead of an x to the third, is a 3 to the third, then that's different. You would not multiply that times the 6. So we'll cover that in a little bit, but just to make sure that you've got that understanding right now. In the rule for multiplication, it is the exponents that you are basically adding together. When you're multiplying the factors, it appears as though you are adding them together as adding exponents. So for example, if we have x squared times x to the third, then we have x to the fifth. Same thing when we have 3 to the fifth times 3 to the second, we have 3 to the seventh. And so this is what I was just alluding to in the last slide. Notice that we're not multiplying 3 times 3, getting 9 to the seventh. The base stays the same, so make sure that you don't make the mistake to be able to multiply the base. The base stays the same. You're multiplying the exponents, which is adding the exponents. So in this case, what we have down here is 2a to the sixth times 8a times a to the fifth. And so we are able to multiply 2 times 8 because notice these are coefficients and not bases. And the difference between them is up here. Notice that the 3's have an exponent on them, and the 2 and the 8 do not have an exponent. The 3's are a base, the 2 and the 8 are coefficients. So if that doesn't make sense, rewind it, go back, and make sure you lock that in because it's going to be really important on being able to solve these. So finish solving these out. 2 times 8 is 16. A to the 6th times a to the 1st times a to the 5th. You're just going to add those exponents up, so that 6 plus 1 is 7 plus 5 is 12. And so you end up with 16a to the 12th. So this is what I was saying earlier, and so just again, make sure that you are not multiplying your bases together, and note the difference between the coefficient and the base. Oh, dividing is very similar, except for it's the opposite of multiplication, which if we're adding the exponents in multiplication, then it makes sense that we will be subtracting them in division. And we'll also be treating coefficients and bases the same way. So when you look at this, you can say, okay, sorry about this. Let me get that off of there. X to the 7th over x to the 3rd. If we are subtracting the exponents, then basically we're left with x to the 4th. Notice that's a positive number. Same thing in B. You're subtracting the exponents, so you have 4 to the 3rd. Notice on C, you are dividing the coefficients, so you end up with 3a to the 3rd. And the same thing for D. And notice the coefficient is negative 6, so that makes the final answer -4 for the coefficient. And again, you're just subtracting the like terms, the m and n in that problem D. So one thing to note is that if you end up with a negative exponent, so if you have a larger exponent in the denominator, in this case we have x to the 4th over x to the 6th, when you subtract that, you end up with x to the -2nd. We want to end up with positive exponents, and so what you will end up doing is you will take then and put the answer with the negative exponent underneath and make that a positive. And so you end up, by putting the negative exponent as the denominator, you end up with 1 over x squared. Let's go ahead and look at that, what this looks like in an actual problem. So negative 12a over 4a to the 5th. We'll go ahead and do our division here, and negative 12 over 4 is going to be -3, and a over a to the 5th is going to leave us with, if we subtract those, we're going to end up with a negative a to the 4th, which is not what we want. The coefficient will stay on top, but our a to the 4th will end up going down below so that it is a positive exponent. Now, as you go along, you will probably start to see these make a little bit more sense, and you'll start to be able to do them just with visual. I'm going to do this verbally and then walk you through it so you can then do it, so we can do it writing it down. But see if you see this. Right now I'm looking at 2 divided by 8. I'm looking at m to the 6th over m to the 3. The 6 is bigger up top, so I know that I'm going to have the m's on top, and n over 2nd over m to the 3rd. There's more n's on the bottom, so I know I'm going to end up with n's on the bottom. So let me go ahead then, and I'm going to erase this so you can see what I mean by this. And so by doing the problem, if I go 2 divided by 8, I'm going to end up having this as 1/4, or 4 on the bottom. If there's 6 m's across the top, m 4 5, 6, and 3 on the bottom, 1, 2, 3, then those are going to cancel, so I'm going to end up with M3 on top. Same thing can be said for the 2's. If there's 2 N's on top and 3 on the bottom, I'll end up with an N on the bottom. So my answer will be M to the third over 4N. So as you do these more and more, you'll probably be able to see these a whole lot easier. Okay, this concludes the video for 6.3.